A set S is a subset of another set T if every element of S is also an element of T, and if that's the case, we write it using this notation here. So let's look at a couple of examples. So I've written down two sets in list notation, S and T, and then I've written down one set in set builder notation. So V is the set of all X, where X is a vowel. So let's write that as a list. And so we just have to write down all of our vowels here. So A, E, I, O, and U. And now we can attack these subset problems. Is T a subset of V? Well, it would be if everything in T was also in V. Is that true? Let's check. O is in T, and it's also in V. E is in T, and it's also in V. I is in T, and it's also in V. So yes, T is a subset of V. Alright, let's go on to the second question. Is S a subset of V? We can check this in the same way. A is in S, A is also in V, B is in S, B is not in V. So the answer here is no, and that's because B is in S, but B is not in V. We can actually write that one set is not a subset of another using similar notation to the subset notation, just with a slash through it, so like this. And finally, let's go on to the third question. Is T a subset of S? And you can see right away, the same way that we did number 2, that it's not, because if I look at any of the elements in T, they're not in S. So you should be able to write down your own reason for that one, but the answer is no. And finally, the last thing I want to say about subsets for this video is talking about equality. So if I have two sets S and T, and S is a subset of T, that means everything in S is also in T. If it's also true that T is a subset of S, that means everything that's in T is also in S. That means that S and T have exactly the same elements. And in that case, we say that S and T are equal, and we write S is equal to T.